Hey everybody, this is Larry. This is me going over Q2 of the recent bi-weekly contest, maximum sum obtained of any permutation. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this problem. This seems like or feels like a pretty tricky one for me, as in terms of implementation for a medium, for a Q2 anyway. So basically, the idea is greedy, and I think people can think about how to do different ways of greedy. But the way that I think about it was that given these requests, I would, the naive solution would be maybe something like, okay, so let's say given these requests, you can see that you put them into buckets. You can see that there's 0, 1, 2, and then the second one is 1, 2, 3, and then the last one is just 1, and then you can maybe do something like add more or whatever, right? And then if you sum them all up, you can see that on the 0 index, there's 1 entry. On the 1, there's 4, and on the third index, but index 2, there's 3, there's 2, and then 1, and so forth, right? And the greedy happens because you can choose any permutation. You basically want to assign the biggest number to as much as possible, right? For example, given that this is the array, we want to give the 10 to the 4 because 4 times 10 is going to be bigger than other numbers, right? So that's the idea that we're working with, and that's the greedy. Let me know if you have trouble seeing that in the questions below or in my Discord. But that's the basis that we're going to build on. And for me, that one has a bit of intuition, so I don't know if I need to explain that one more. But basically, you're just greedy because you could think about it like if you have a 10, let's say this is sorted. I guess this is actually sorted, but let's say it's sorted. Given a 10, giving it to the biggest number will always be bigger than giving it to a 3, for example, right? So that's the kind of greedy intuition, because you just sum up the components, right? Okay, so given that, if you just do a naive, maybe a way to think about it is like do a naive for start n in request, for x in range from start to n plus 1, because it's inclusive, count of x increment, and then we just do them sorting afterwards, right? The problem is that in this loop, start and end could go from 0 to 10 to the 5th, or 100,000, right? So that means that, and because there are 100,000 requests as well, that means that this loop can take 100,000 can run up to 100,000 times, and this loop can take 100,000 times. And that means that these two for loops will take 10 to the 10 or way too long. TLE is what it time limit exceeded is what this is equal to, right? So you have to do some optimization. There are a couple of things that you can do to optimize the way that to get it down to linear time, or sorry, n log n time is the way that I did it, but yeah. So the way that I did it is I did a sweep line algorithm and sweep line is one of those things that actually comes up a lot on intervals and stuff like that, and especially on LeetCode. I mean, it comes up in other places in real algorithm stuff, but in terms of LeetCode / competitive, it comes up a lot of interval stuff. So that's basically what we did here. So if you're interested in a sweep line algorithm tutorial, let me know. I might do one up at some point, but for now, I'm gonna use that premise to so that's your prerequisite. You have to do your homework for me to explain the solution. And for me, for each request, I just keep track of the start and the end by adding the delta. And basically, what I'm doing is, and actually, I think you could also do this with binary index tree. I was thinking about doing it that way, but I just didn't want to spend too much time on binary index tree. So if you want to upsolve it with binary index tree, because I was worried about off by ones, ironically, because I spent too long on this one anyway. So, but yeah, that was my intuition. So you could solve this the way that I did, or with binary index tree. But the idea is that, say, given 0, 2, at 0, we're gonna get a +1 in total, and then it's going to go to 1, and then at 1 it's going to be, you know, we open 2 new intervals, so that 1 will have 3 intervals. I guess technically if you count this one, then it's 4 of it. Okay, so you just do. So now it's at +4, and then the next number processed would be the 2, and it is a -1, so 2 would be -1, so now it's +3, meaning that only 3 intervals in it, and then 3 is the next one to get popped off, so that's going to be +2. Also, oh yeah, because basically these things are inclusive, so we actually have to. I did this incorrectly, so you have to do it a little bit correctly. But the popping off is on the n+1, as you can see, right? So then in this case, this one we pop up this second one for the end of interval, so that's actually at 2, so that's gonna be 2 + 3. And then same thing, we pop up the 2, so now on the 3 it's going to be +2, and what is the +1 +4 +3 +2, right? These are the number of like, if we look at an interval, the number of intervals that are within that number is in between, and then here finally you go back to 0, right? So that's kind of the sweepline algorithm. And I just do this thing where, so if you know, I take it, given n request, we convert it to n, we convert it to 2n events for the sweep line, and then we sort it, which is n log n. So this is going to be an n log n algorithm. We just basically do the algorithm that we talked about here, but the thing that you have to do well is that, okay, so this is not a good example of this, but let's say this is from 1 to 10, right? Well, now you're going to pop off at 11. So now what I did is that I just populate the numbers in between, so that, for example, in this case, this is what we're going to look at the interesting points, quote unquote, and then, you know, we just have to populate 5, 6, 7, and all the way until 11, right? So that's basically what I do here in this code, by using -1 as a flag of some sort, and then just, you know, doing the prefix copying of the previous one. And then after that, as we said, we just do the greedy by sorting, by reversing the sort, or, you know, by sorting it by the count that is most. In this case, for example, this would be 4, 3, 2, 1, and then we just go through the entire array in a greedy way to sum it all up. Remember that nums, in this case, of course, is sorted in reverse order. And I ate a 5-minute penalty because I forgot the mod. Usually I write it out. I didn't notice this, but I think I was just too deep in thought, because this one was harder than I expected for Q2. But yeah, that's all I have for this problem. Oh, I have to go over complexity. So this is n log n because we sort once here, and we also sort in events, but everything else is going to be O of n, because, for example, this is O of n because it literally has an n range. This is also O of n log n, but this will only, this is a little bit obfuscated, but it only has n indexes, right? So it's also going to be O of n. In terms of space, it's going to be also linear. We just create events and counts, which is linear in the size of the input. But yeah, so linear, space, n log n time. Cool. Let me know what you think about this problem. I think this was a bit hard for a Q2, to be honest. Maybe there's for this, the way that I did it, n binary index tree. Let me know what you think. I think if the request length was much shorter, then it would be a more reasonable problem for Q2, but this was a 5-pointer, so I guess they actually graded it in that way. But yeah, let me know what you think. And yeah, and you can watch me solve it during the contest next. Thank you. There's another one. Oh, I forgot to reverse it. Oh, I forgot. Oh, really? Oh, oh. I knew about this one, but I forgot it. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button. Join me in Discord, and let me know what you think. I'll see you next problem. Bye bye.